Hi, Mr. Chong. Good afternoon.
Hi, good afternoon.
Yeah. You can start now. Mr. Tay, would you mind please on your camera, Mr. Tay, so we can see you also? Okay. Mr. Chong, you can proceed. Thank you.
Okay then. Hello, Tay. How are you?
Hi, fine, thank you. How are you?
You're in Time Center. Is it?
Yeah,
Oh, great. Okay. We are all keeping social distancing from from our
it's
office.
okay. I'm the only one here.
Oh, that's good. That's good. Yeah. A very big welcome to all the participants who've already signed up and in. Um, Mr. Tay had just come off his earlier session, so he's really fresh. He just had his coffee, so I think we can get on to it because the topic that we have today is really something very exciting and very interesting. On my session this morning, I did mention. In fact, we spoke at length about the applications of the Uniform Building Bylaws, which is really just a law, not exactly a guideline and all that, and how MS1163 is the one which is a standard of which is more informative and it acts more as a guideline as to how we apply and do our designs. And Mr. Tay is Engineer Tay is definitely a very instrumental person in the development of all these standards. Okay, I'll a very brief introduction of Engineer Hao Giang. Engineer Hao Giang is a very experienced and qualified fire engineer. He's a graduate of the Harriet Watt University and the University of Edinburgh, Scotland, with a Master's of Science degree in Fire Safety Engineering, very specific fire safety engineering. As a principal fire consultant of Fire Safety Engineering Sendirian Berhad, he has over 30 years of experience in fire engineering and in fire safety engineering. His company provides advice, consultancy services, and training to corporate clients with a holistic approach to sustainable fire safety management and for business continuity. Fire engineer Hao Giang is the past international president and is the current trustee and board of directors of the Institution of Fire Engineers. He is the current vice president of the Institution of Fire Engineers Malaysia branch. Engineer Hao Giang has also been involved in the Malaysian standards development under the Department of Standards for many decades. Yeah, ever since I came back, the moment I got myself involved in PAM and into fire safety engineering, Engineer Hao Giang was already there. He's really a pillar of support and encouragement, and I would say that I owe an awful lot to his 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 great pillar. He's always there for our reference. And he's also one of the major authors of the Guide to Fire Protection in Malaysia, the red book that became the black book and then eventually became a blue and the red book. Yeah, okay, that's a very Mr. Engineer Hao Giang is definitely one of the instrumental authors of that book. And over the years, he's been invited as a speaker at international fire conferences in Europe, Asia, USA, the Middle East, India, and South Africa. Yeah, Malaysia, Boleh. We are definitely all over the world now. And he's currently being featured by the Chartered Association of Building Engineers as a fire safety speaker at the international webinar. So we definitely have a person of great credentials over here delivering us our paper today. All right, the way we'll work is that we'll be starting immediately. Hey, you'll have the entire session, and I believe when you're ready to stop or when you're finished, towards say by about 5 o'clock or at the latest 5:10, we can then move on to our question and answer session. Yeah, we'll take it from there. All right then. Okay, I'll hand the screen and the time
Thank
to
you.
Engineer Hao Giang.
Lee Siong, thank you very much for a very kind introduction. All right, I'll try my best. Well, good afternoon, ladies and gentlemen. What I'm trying to do this afternoon is actually to share with you a very informative and performance-based Malaysian standard 1183 code of practice. This particular standard is so thick; it's about an inch thick. You can then put it under a pillow. your pillar is too low. And it's very expensive. It costs about 473 ringgit. Now, I can't finish the whole standard, but I pick one section, section 5, that is actually relevant to practicing architects, and that is means of escape design. Fire safety, there are so many topics, but I always pick the topics that is more critical, more essential, and more relevant. So let's look at what is actually stated in MS1183. Now, if you look at the previous standards, is very, very different in the sense that this particular standard, why is it so thick, is that because it explains all fundamentals of why do you need to do the design, which is also an educational document and is very, very interesting. It also does not limit you to prescriptive design. It gives you a lot of leeways to actually use your judgment, use your assessment to actually provide the best fire safety design. Before that, for those of you who have actually missed my first chapter, you can actually sign in to the free webinar on the 4th of March 2021. It starts at 7 p.m. to 8:30 p.m. This is launched by the Chartered Association of Building Engineers. If you can send an email to the email that is listed there, you can actually be registered. All right. Fire safety engineering. Normally, when we talk about design fire safety, we want to look at fire safety engineering. And fire safety engineering for built environment actually is application of scientific and engineering principles for the people, property, and the environment. Is to protect people, property, and environment from fire. Okay, so you need to actually focus on this. If you cannot achieve that, then you have failed in your design. This is, you can look at that. This is actually the standard. As I say, is quite expensive, but then it is relevant, all right? And it's very, very interesting. This is actually from BS 9999. In section 5, designing means of escape, you look at principle of means of escape, evacuation strategy, internal subdivision and spatial visual orientation, designing means of escape, and then education of risk. They broke it down into several subsections. And then continue with minimum package of fire protection, horizontal means of escape, vertical means of escape, and additional means of fire protection. So during my last session, I talked about there is a difference between horizontal means of escape and vertical means of escape. Principle of means of escape is actually provision for adequate means of escape should be determined and assessed against the development of the fire threat, time taken to egress, together with expected reaction and subsequent actions of those responsible for the management of the building. So the assess against the development of fire threat, this part at the moment is not taken into consideration. That's why I always say that for professional architects or engineers, it's the same. At the moment, the fire module is lacking. If you design a building without looking at the fire risks, the fire threats, and also human response, then there will not be a complete design, all right? So the objective of means of escape design is to limit the time taken to travel through the areas of a building which could potentially be exposed to fire and smoke. This one eventually, I have no time today, actually involve smoke control and management as well. Because for people to escape, we need a clear smoke height of at least 2.5 meters, which if you use actually a dilution method, ventilation dilution method or pushing method, nobody can survive, all right? I will not elaborate here, perhaps in another webinar. Now, if you look at this particular graph that is actually inside the MS1183, is actually very interesting. Give me a second. This is talking. Okay. So actually, when you look at means of escape, you can look at ignition. That is number 3. The fire started when it's small. and then you will then be detected by the detectors. As the fire grows further, people or occupants will be perceiving the audio alarm that is being raised. Okay, and during this period, the fire will start to grow slowly until develop into a full-scale fire. Now, once you hear the alarm, what is important is actually the response time. Okay, do you actually take time? How much time taken to respond to the alarm? You decided to actually get up, walk to the door, go to the protected corridor towards the fire escape staircase, or you're too busy because your boss tells you that he needs you to finish the report before 12. Then if you go further up, you'll be looking at 8, life safety strategy completed. That means during this particular period, from the moment the fire developed until you actually started to evacuate, this is called required safe egress time. All right, because until you get out of the building, then you complete the objective of egress from the building. Now, between here and when the fire grows to an extent whereby you cannot survive inside the building, this period of time is crucial. This is called tenable time, all right? And this is called available safe egress time. The time taken before you decide whether you live or not in the building. So the reset required safe egress time must always be earlier than the available safe egress time. Right? That's where it developed into a full-scale fire and nobody can survive. In fact, probably before this, if there's enough smoke particles, you will not be able to survive as well. Hence, egress is actually very, very crucial. All right. Considerations for means of escape design. Each building type should be allocated a purpose group depending on the occupancy characteristic. Of course, you got all the schedules to refer to in UBBL. And the fire growth rate associated with its use. At the moment, this part is missing. We do not have the data bank. That's why I always say, so for an architect to actually design a safe building, you need to actually have a better understanding of fire behavior, smoke danger, things like that. Then only you can assess the risk. And then the data that is being stated in the UBBL becomes more meaningful. What do you mean by 1.12 second? Per meter of egress time horizontal, and what do you mean by 80% of that going down a staircase? It's meaningless unless you look at where is the fire happening, how big is the fire, and who are the people you're looking at doing the egress. Are they senior citizens? Are they children? Are they people with disability? Or are they all assuming to be healthy young Malaysians of all 20 years old, identical physical condition with the leg length the same length? Then only they can then move uniformly at that rate. We are now using one single rate to actually calculate the egress time, which I think is grossly insufficient and need to be reviewed in this modern age. All right. The time to escape to place of relative safely should be less than the allowable traveling time. So there's two ways. One is that you go down vertically, egress to the building, or for special category of buildings, like healthcare facilities, hospitals, you can't move them. So you have to actually move from one compartment to a safe refuge area. But that's a different ballgame altogether. Major stage of occupant response that should be considered in determining the provision of means of escape are as follows. Factor for mass evacuation. Time to detect a fire and sound an alarm. Now, talking about sound and alarm, if you go back to look at the response time, do you think that people, when they hear the alarm, they will then start to prepare to move and then move? The answer, of course, is no. 85% of the people in the world, according to statistics, does not respond to fire alarm. You ask yourself, if you're in a shopping center, you hear the fire alarm, do you continue shopping or do you walk out of the shopping mall? Let me tell you, I'm the only one, oh, probably 5,000 in KLCC, every time the alarm rings, I'm the only one that walk out like, looks like idiot. But I know in my heart that if anything really happened, I'll be the only one that survives. Okay? Pre-movement time, which consists of recognized time and response time. Travel time, including queuing to a place of relative safety. And movement within a place of relative safety, protected corridor, smoke lobby, escape staircase, or adjacent compartment. All these, provided the relative safety compartment are all protected, free of smoke and flame. And that is another module that we have to look at, why protected corridor must be pressurized and not using it as a purging compartment. All right. Then you've got relationship between these two factors in figure 2. Okay, this one will show a clearer picture. Ignition, then you got detection time. This is the period. Sometimes it takes about 2 to 3 minutes, depending on the sensitivity of the detector. So fire started, pick up by detectors. Alarm, the detectors will then send a signal to the fire alarm panel. Alarm will be raised. This is where the audio visual alarm raised. And then you, upon hearing the fire alarm, sometimes it still take probably about a minute for you to recognize that it's actually a fire alarm. Okay, then you make up your mind whether to move or not, right? So this is pre-movement time. It depends. According to performance, a lot of performance-based engineer, they put about 3 minutes here, which I also disagree, because if everybody ignores it, this becomes infinity. All right, so everybody will still staying around, and at the end, you exceed your available safe egress time. So when you start to move until you evacuate, this is actually available safe egress time. All right, this is the period until you evacuate. This is the safe egress time. Sorry, this is available safe egress time. Now, number 6 is actually the required safe egress time. That means the time that you require to actually get out of the building. All right, get out of the building before it becomes untenable. Red means that the temperature or the smoke level intensity in the building is already too high for occupants. All right. So there are 2 primary early stages that occur before the occupants start to move to escape. One is time from ignition to warning using manual automatic detection, time to alarm. Second one will be time from warning to the start of movement to escape. So it's 2 and 4. So these are the 2 crucial timing before you look at how long it takes to go down the staircase. But the question I'm also asking now is, we keep designing higher and higher. All right. In the last paper, I look at Saudi Arabia is building a building that is 1 kilometer into the sky. I don't think we don't look at that. We look at, let's say, our tallest building in town now is 118 story. Now tell me frankly, how many of you think you can walk down 118 story within the fire escape staircase in one go to stay alive? I think most of the answer is no, unless you're very fit, okay? And it's not only you. You are only one of the participants evacuating downwards, descending in the fire escape staircase together with the rest of the occupants. If somebody in the front is slower than you, your flow will be disrupted. And then somebody behind that's impatient probably will start pushing and then end up with a stampede in the fire escape staircase with some broken legs and all that. And then eventually the whole staircase will be jammed. Now, so we are looking in a realistic design that high-rise fire escape staircase, are they really safe? It's not just code compliance. It's not prescriptive. You put a figure there, the width of the staircase can take so many people, complying to the floor density. No, I think you could seriously look at whether can you really get everybody out of the building. All right. This is fit for purpose, performance based within prescriptive code. All right. Design consideration and movement to escape in many cases might not be along the optimum travel route because If you look at our DBL, we are supposed to take only 50% of the egress as effective, just in case the other egress path is being blocked by smoke or fire. So in that context, now you understand why you need more staircases. Why do you need to make sure that the integrity of the protected corridor, smoke lobby, everywhere is being protected, all right? Before you look at pressurization, smoke control. And also, you don't forget that they are also queuing time. Doesn't mean that you go to the fire escape staircase, the whole staircase is clear for you to descend. Sometimes there is a crowd waiting to actually going through that particular door. All right, so all these must be taken into consideration. Through many fire incidents, there's always good feedbacks, and this is one of them. Human behavior always exists following the way that they are familiar. So, assuming that this is a shopping mall, and if you enter from the front, unless you're very familiar with the layout, normally for people who visited this mall the first time, if they are actually at the back and there's another exit that's nearer, they will not use it. They'll backtrack all the way to use the route that they are familiar. This is human psychology, all right? Has been observed in many, what they call fire incidents. Research-based means of escape design data. This one is also very interesting. You can take a look. Now, we always design using fixed data that's given to us, and we expect everybody can actually use it. But if you look at Scandinavian countries, they actually measure the person's space required during egress. You cannot take it that a person is moving just very close to each other, because psychologically you will never. And you also will never move along a corridor touching your shoulder with the wall. So when you look at the egress design, you've got to actually take all this into consideration. The research done in Sweden is very interesting. In fact, that they put a camera on top to look at actually the perimeters of a person when they are moving, the legs in front, the legs behind, and when they are standing still, all right? So you can see that this is actually more performance approach using realistic data that has been established. So you're looking at about 0.9 meter with 0.56 meter of a space that you need to allocate per occupants. Then with this, then you look at how many persons are actually moving along the corridor. It's no more just floor density. Those are prescriptive. This is actually realistic. And with this, at least the end result will be different. Then you want to look at actually in the staircase, this is a stair trap. You've got the wall, you've got the handrail, and you need actually the spacing, all right? Because as I say, nobody will walk touching the handrail. So you need another 6 inches. So this is the effective width of the egress path, and not this that is being stated in the UBBL. And this is another illustration whereby that is actually the width that is normally designed, but the effectiveness is normally not 100% because nobody will walk touching the wall. All right. So this is how people evacuate, and you can see that they are not like soldiers, 2 by 2 and fill up the whole corridor. No. So if you look at egress, there are a lot of other factors that it needs to be considered. They actually do a simulation using real objects or real subjects going down doing evacuation, uninformed evacuation, and they use cameras to track them. And then all these data are recorded in the computer, and then eventually the data are being analyzed. And this is actually the first time that a lot of studies being conducted on evacuation. I believe this, a lot of the research has been carried out by MU as well in Malaysia. Okay, let's look at egress on doors. Now, doors actually, this is a plan view. This is a door, this is a lever handle, this is a door frame with a stop, okay? We actually, a lot of times, look at the doors, we normally take from here to here as egress path. No, it's not, because you got fire stop, you got a door stop here, and then also you got thickness of the door, and also the protrusion of the lever handle. So if you look at seriously, if you are taking even this width, it's not realistic, because the actual effective width is from here to here, all right? Because as pointed out through the research, nobody will walk touching the surface. So you still need a gap for the occupants to stay away from any objects. Okay, so if you were to design using the prescriptive code or prescriptive data, you are again designing what we call that is egress width of this nature, which in realistically is not applicable. Remember the research data provided, you can see that you need space, all right? Front, back, and the side. Design considerations. In an emergency, there should be sufficient escape capacity to allow all the occupants to reach an area of relative safety. Fire integrity is critical. It's because fire doors actually cut all the compartment openings. And fire doors in Malaysia, there's no maintenance. If that goes, you just do not have your protected corridor, your smoke lobby, or your fire escape staircase. Go back to the condominiums, just go and do a routine inspection, all right? Whenever you are in a hotel, whenever you're in a shopping complex, just take a look at the fire door and tell me that most of them are working. Everywhere I go, I do risk assessment. I'm telling you, I'm really worried because most of the fire doors are not working, either sagging or they are not closed and latched. You need a door to close and latch, okay? What about this group of people? Do we actually consider them as physically able to descend a building of 40 to 80 stories during a fire incident? If not, has any solution been actually provided in design? In fact, if you look at now in China, in Hong Kong, lift evacuation becomes mandatory. Okay? Of course, that is a different ballgame altogether. You need to actually look at it. It should be managed, should be manned, should be drilled, should be trained. And all these people are not going to be included with the normal occupants. They're supposed to be pre-selected, predetermined, and then they're supposed to be grouped together and evacuate through fireman's lift. They're supposed to be differently managed. What about stampede, panic? When they go down a corridor, there are people who walk very slow, obese, or clutches, people who are not healthy, and there are people who are young, who are actually aggressive, who are fast. We can already see that there could be a stampede in the fire escape corridor, fire escape staircase. So, has there any plan of dealing with a situation like that? The moment you have a stampede, it blocks up the entire fire escape corridor. Then what's going to happen to the required safe egress time? There's none. What about stride and traveling speed? At the moment, we only use one constant data. I think it's about 1.12 meters per second. Are you saying that everybody's leg is the same? Everybody walk with the same stride at the same speed? Definitely not. So I think it's time that we should review whether the horizontal evacuation speed perhaps should be broken down into different age group. And then you got to again look at the percentage of the age group within a building. Then that will then provide a more realistic. Of course, nowadays we have computer-aided software to actually plan let you have a preview of what actually happened during a mass evacuation. All right. Design considerations in large premises or super high-rise structures, phased evacuation is more practical, which is also beneficial for egress with the people with disabilities. Now, if you cannot evacuate everybody from a super high-rise structure, then you need to actually look at this. Motivation to escape is important, all right? And research into several major fatal fires and evacuations suggests that in mega complex, people are difficult in recognizing the threat from a fire elsewhere in the buildings. For example, if is in a shopping mall, fire could have actually happened in one end, and actually you are at the other end, and even though the bell ring, you look around, life is normal, everybody still carry on shopping, you don't see smoke, you don't see fire, you don't see the threat. But you know, smoke can actually propagate very, very fast. All right. So the other danger I always say is that if you went in with a family and you're split up to different areas, different shops, do you think you will just leave even though you see smoke and fire? Or do you go around looking for your family members? You see, human behavior is irrational. Do we have enough study into all this? Or do we just assume that the moment the bell rings, everybody's going to walk out? Answer is no, definitely. You think about it. People are also likely to underestimate how quickly a fire can spread. In a fire disaster, the uncertainty of the situation in its early stage is usually compounded by a serious delay in warning the occupants. So there's a lot of factors that we need to actually look into and consider. All right. Exit size. I'll talk about it after this. This is actually a research career and BRE in the UK, British Research Establishment. I was there during one of the experiment, and this is the door, and exit sign is here. We always put the keluar sign on top of the fire door as required by UBPL. Now, you look at what happens when the smoke start to produce. Now you tell me, can anybody see the keluar sign? If cannot, then where do you think people can go and find the fire escape staircase? Having said that, remember that where do we put all the emergency lighting? Along the ceiling. In any buildings where there's a fire, where do the smoke goes? Ceiling. They flow along the ceiling. I can tell you, if you look at the emergency lighting, they're all in plastic casings. Do you know the smoke particles, when they leave the fire source, the temperature is 250 degrees C. What is the boiling temperature of the water? 100 degrees. Some of these emergency lighting, I don't even know whether they can sustain the attack and the ferocity of the smoke particles. Not fire, we're not even looking at fire. Each of these smoke particles are burned or particles that carry temperature, all right? So what are the evacuation strategy? Primary objective of any evacuation strategy is to ensure that in the event of a fire, the occupants of a building can reach a place of ultimate safety outside the building. This one also poses another issue. In fact, last time when I was invited to deliver a paper for the Private Association of Hospitals Malaysia. So when I talk about assembling point, one of the hospital's safety manager so proud, and Mr. Tay, we all taken care of that. I say, where's your assembling point? He said, outside the building. And you know this hospital is where? Glen Eagle Hospital in Jalan Empat. I say, yeah, great. All your patients outside. Next morning, the newspaper will be saying that patients safely evacuated, but mowed down by the traffic of Jalan Empat. So again, you see, assembling point is not just anywhere, as long as you're outside the building. I also asked them another question. What happened if it's pouring outside thunderstorm? Perhaps they should actually go and employ the BOMO with the fire coconut to make sure that during the day of fire, everything in the weather is actually excellent. So there's so many things that we cannot predict, all right? In Malaysia, if you look at any what they call evacuation plans, they stick on the wall along the lift lobby. Normally, they are full of so many informations that you can't even have time to read all of them. So I think the modern evacuation plan should be very simple. The rest of the what they call it, the information is not necessary, should not be included there. So you want to indicate the arrow of flow of where to get to the nearest fire escape staircase so they can evacuate safely. These are some of the examples. So egress should be functional based, all right? It should be enough fire exit or sufficient width so that all people can escape safely within requested egress time. And also, as I pointed out just now, according to our requirement, only 50% of the story exit are to be taken into consideration. So in the past, we always look at mass evacuation, even for high-rise now. We look at mass evacuation, but then what I noticed is that drills are being conducted yearly, but there's no logging of data of how long it takes all occupants to be evacuated. And then there's no study or observation of the behavior of the occupants within the building. There should be more in-depth studies of behavior of male, female, different age category. Then with all these data, perhaps you aid all the architects in the future design of high-rise evacuation. For super high-rise, definitely you will not be looking at mass evacuation, which we are practicing now. We should be looking at phased evacuation like Petronas. They have very well prepared evacuation program. I've been briefed a few times there. Every time the international president of IFE is in town, I'll brought them there because there's our iconic building. And then they will conduct a safety briefing for all of us. And they are actually very, very thoughtful of making sure that the moment there is a fire alarm, they have an internal ERT, emergency response team, to go investigate. Meanwhile, 10 floors of occupants will be moved below the fire floor, just in case during this time, because it's going to take some time. And the rest of the occupants will stay and continue working until if it is confirmed that there's a fire incident, while they're still trying to put out the fire, then the real evacuation mode will be in place. But it's only 41 floors because Twin Towers have a sky bridge, and the occupants of the above the sky bridge will be asked to come down by staircase, cross over, and then taken down by high-speed lift. So you see, we have actually a very good design in the sense that it can be strategized to actually reduce the required safety egress time. Delayed evacuation refuge compartment, these are more for healthcare facilities like hospitals. I always say hospitals, you need to practice zero fire policy, and it's almost quite impossible to evacuate the whole hospital. I have no time today to talk about that. Perhaps another webinar just on issues and challenges of fire safety in healthcare facilities. Fire resistance door sets are actually very important. It's because it actually protects all the compartment walls. You can have a 4-hour door, a 4-hour wall. If you do not have a working or fully operational fire door, then your integrity of your 4-hour fire-rated compartment wall will be compromised. Okay, and yet there are so many things to look into for the door to operate properly. Your door got to pass the test in serum of not only integrity but insulation, but also they got to pass the cyclic performance test. Now, a door consists of so many components. Iron grease. You got hinges, stainless steel hinges. You got automatic door closer. You got lock sets, latch sets, and for double lift, you got auto bolts. Now, all these are actually applying different stress onto the door leaf. And so the door that is subjected to wear and tear when you open and closing it will not last forever. But yet in Malaysia, our fire door have no lifespan. In buildings that is already 40, 50 years old, you can still find the old fire doors there, which already expired. Okay. Again, I actually have another paper just on this particular area of the research carried out by my MSc degree student in UIA, which is very, very interesting because I actually confirmed through her research thesis that doors really have a lifespan, because in Syria, we test all the fire doors to 100,000 cycle. Okay, opening and close 100,000 times. That means if the door or fire door that's on the market have that, by right, they should be replaced because you test to that limit. You cannot go beyond that limit. And yet, through her research, one of the busiest door of a shopping complex, I won't tell you which one, opens 2,000 over times a day. Now, if you take the 100,000 cycle divided by 10 years, assuming the door actually can last for 10 years, every year, any fire door can only operate 10,000 times, right? 100,000 divided by 10 is 10,000. Divided by 365 days, which means that every fire door can only open and close 27.4 times a day. And yet, the door that my student actually did research, that we took statistics, actual performance statistics, operates 2,686 times per day, which means that the lifespan of that door has been shortened to a few months, and yet it's still there after 40 years. Okay? So for these particular doors, you can refer to Malaysian Standard 1073, Part 3, 1996, with Amendment 203. We are the only country in the world that tests the performance of the door. I really checked. No other country did that. Why fire doors are critical to life safety? Because it's part and parcel of means of escape design. Without that, you have nothing. If you look at the fire escape staircase, every floor is protected by a fire door. If you compromise that fire door, you don't have pressurization inside the staircase. And if you do not have pressurization in the staircase, smoke can then get into the staircase, flows upwards, and nobody can escape. Okay, so they are just like tires. Can you use your tires for more than 5 years? No. Even though you park your car, you seldom use your car, the tire lifespan is still 5 years. After that, you have to change. Otherwise, the rubber compound hardens and you lose your grip on the road. Okay. These are some of the examples whereby if you look at our fire doors, are they well maintained? No, they are being kept in open position because the door selector is not properly adjusted. And yeah, the door is there, but imagine if the particular corridor or the compartment have a fire, the smoke, everything, the flame will then come through. So you lose the compartment's integrity. So many times the doors will rage. This is actually even worse. This is actually fire escape staircase fire door. And across the other side actually is car park. So when you open the ground floor doors and wedge it open for ease of traffic, you imagine that if the car park, the risk is higher than the shopping complex. And when there's a fire there, the smoke, whatever, comes into this area and floats upwards. Again, nobody can escape. Sorry. So if you look at fire escape staircase, the final exit should actually open to what we call outside the building. All right. You cannot land a fire escape staircase within the building. Which, if you go to America and all that, some of the building did that. Which means that when you travel all the way to ground floor, you still got to negotiate your way through the foyer outside the building. In Malaysia, that is not allowed. This particular diagram demonstrates how important is actually fire resistant door set. Imagine if that is a fire escape staircase of 60 floors and the fire happened on 5th floor and the doors are not maintained. the smoke, everything will then get through and goes up while you and your family are coming down. You can imagine what is going to happen. It's going to be a disaster, just like Grenfell Tower. Smoke gets in, it's not because of anything. It's because in the past, they believed in putting the landing valve of the wet riser system inside the staircase landing. So when the firefighters connect the hose and pull the hose, 2.5-inch hose, through the fire door onto the floor to fight the fire, smoke, the door is kept in what they call semi-open position because they can't close fully. So the smoke, everything goes into the fire escape staircase and is actually filled up with hot, thick, black smoke, resulting in 72 victims. So very, very crucial, all right? Petronas, you can see that we have, I already explained, we have a sky bridge, which is good. If you have a fire here, everybody will then come down by staircase. Occupants here, if it's confirmed fire, will then come down by staircase, cross over, and then taken up by high-speed lift. So to manage an 88-story building, actually, we split into 44 floors on it, which is actually very good. But all these are actually managed. Evacuation by lift cannot be free for all by the occupants. It has to be by the management with crowd control technique being trained, okay? And also they must have enough lift capacity, taking into consideration of the density of the occupants. Now in Hong Kong and China, lift evacuation is mandatory. Refuge floors also is now a feature that is essential for high-rise or super high-rise commercial buildings. The point about refuge floor, the purpose, of course, is that, as I pointed out, it's impossible for everybody to actually walk all the way down. If this is 118 story, you got to think about it. Even though you are, let's say, physically very, very fit and you're young, do you think you can still walk down 118 story in one go, non-stop? If you cannot, then you can imagine the rest of the category of people: senior citizens, pregnant lady, obese, children, people who are injured, people with disability. If you mix everybody inside a staircase, I don't have to tell you what kind of disaster are we looking at. In Hong Kong and China, it's mandatory now. Also in Singapore, you need refuge floors, whereby you can select the mechanical floors to actually have the space to accommodate occupants who are actually tired when descending through the staircase. They can take a rest here. And this floors, nothing is combustible. Ventilation is not necessary because it's at that height, you have a free flow of air. All the columns, this is steel structure, they have to be protected. And they also got a spray and what they call water curtain system to make sure that if there's any smoke from the floors below, it will not enter this building. But having said that, there's two issues. One is that this, by right, should be, I do not know whether Hong Kong did it or not, but they should be tested actually in a wind tunnel. Because the higher you go, the wind velocity, vertical wind velocity is going to be very, very much higher than on the ground floor. So if you got smoke coming out and if the wind velocity is high, probably even the water curtain cannot stop it. Do you know our twin towers, at the top there's two pinnacles. In a normal day, they can sway up to about 1 meter at the top, all right? So wind factor is actually one factor that also has not been taken into consideration in M&E design at the moment. I've already commented quite a number of years. Now, the other problem is that I asked my friend who actually designed the refuge floor that, okay, fine, you let people who are tired to rest on this floor. But I asked him, what is going to happen to these people? Because when they are tired, especially people who are obese, they sit down. Those who are weak heart, they'll never get up. So comfortable, why should they get up? So I say, you need to actually find another solution to make sure that these people should be managed, There are a lot of refuge floors now. If you look at that, Hong Kong, they actually do that. So if you look at design means of escape, of course, you look at a package of fire precautions to reflect the nature of use of the building, occupants, processes. It depends on whether it's a hotel, whether it's a office block or corporate office or whatever that you actually design for, and that has to be taken into consideration. That means the fire risk, fuel load, whatever, will have to be taken into consideration. And looking at the occupants, especially visitors. A lot of the corporate office, they have security in the sense that they identify all the visitors. And the visitors, because they are not familiar with the protocol of the management, normally they are actually being singled out, and during a fire emergency, they will be taken care of. So there are also certain things that you should not taken into consideration when you design egress, means of egress. So do's and don'ts of means of escape design. Following over all escape routes, including tracks of steps and surface of ramps and landing, should be slip resistant. Some of the fire escape staircase, when I go inside, it's all cement, screed only. So at times it's slippery. So the nosing there should be incorporated with non-slip feature. Potential reverse flow situation in Twin Tower, New York case, because the fireman's lift was disabled, firefighters could enter the building and climb up the staircase. But we all know that architect design doesn't have provision for firefighters counterflow in the fire escape staircase. That's why when you design fire lift, fireman's lift, and all that, smoke lobby, all these are very, very important. For high-rise super buildings, provision of firefighters going up, as I explained, fire escape staircase with the equipment is one of the concern now. So if you look at the new, what they call that, buildings that is replacing the Twin Towers, all these consideration is being taken in during the design. They allow about 20% more width in the fire escape staircase. There are a lot of innovative high-rise structures, and if you look at that, you need to actually look at the design and then come up with proper SOPs for evacuation, because I like the linking bridge, linking part of the building, because it provides more alternative for egress, but at the same time, it has to be very, very clear, because occupants might get confused. Now for Twin Towers, they have an evacuation program whereby all the tenants are briefed about the procedure SOP, and also they are drilled every year. So everybody knows what is to be done during any emergency. How do you design evacuation for buildings like that? Because north direction could become south after a few floors if you turn around. So there are challenges in the modern building. This particular condo in Putrajaya actually designed with jogging tracks. It's fantastic. You don't have to leave the building, okay? Going across and coming down. So this particular jogging tracks also pose different risks, as I say, in terms of evacuation, because it may be confusion, all right, during the evacuation, whereby they thought this could be the safe haven. If you look at MS1183, they also use a flow chart for you to design means of escapes. If you go through this flow chart, at the end of the day, you know whether it's okay or not okay. I won't go through it because it's because of short of time. I will not go through this. Make sure you get a copy of the MS1183, and then you should be able to look at it, because there are a lot of references inside there. Acceptable means of escape. The following means of escape are generally deemed to be acceptable for buildings: door leading directly to outside air, door leading to a protected staircase, door leading to another fire compartment. These are for horizontal evacuation. Open and ventilated staircases, pressurized fire escape stairs enclosed in a compartment shaft, ramps conforming to 1184, radius not 1 and 1 is to 12, suitably design, install, and man evacuation lift, the crowd control management system. Now, if you look at first three items, you're looking at doors. Okay. Other than final exit, you do not need a fire door. The rest of it, you still need fire door. So hence, fire resistant door sets are very, very important. So when you select the door manufacturer or the supplier, make sure that the door they supply fits your specification. I always say that you cannot just let them supply the type of armoury that they tested. You must actually already pre-specify what armoury that you require with the brand, with the quality. Maybe you should call a pre-qualification exercise before the real tender, and only allow those who qualify in the pre-queue to tender. Then the market will shape up, and then they will have to actually test the armoury they will specify is giving you what they tested, because a lot of armoury they tested is the cheapest, might not be relevant to your application. Unacceptable means of escape. Leave except for suitably designed, installed, and manned. So it's not, it cannot be for any building, all right? It has to be what they call that, well thought of program, and then the management must have enough manpower to do that. Fixed ladders, no. All right, that you can climb, that you need to climb vertically, definitely no. Portable ladders, no. Tower operator, manually operated sliding doors also cannot, because all these could be subjected to power failure and get stuck. Escalators are also not. That's why normally escalators, you either have a drop curtain, smoke curtain to conceal it, or a roller shutter to close it. Revolving doors, turnstiles, and automatic doors, no. All right, you cannot use this as part of egress route. Artificial emergency escape lighting. I already pointed out that, you know, now the way we mounted it is in doubt. I prefer the spotlight type of emergency lighting. So you hang it lower from the ceiling along the wall, so at least it's not so much affected by the normal EL that's hanging on the wall, on the ceiling. Sorry. And normally this spotlight type of emergency lighting also are more powerful, and you can adjust angle as well. By the way, emergency lighting also depends on rechargeable battery. They have rechargeable battery, but this rechargeable battery have a lifespan, probably about 5 years. So a lot of the EL, I believe nobody changed the emergency lighting battery. So imagine that a lot of them are also will not come into operation during a fire incident where power failure is initiated. Now, when you talk about designing egress, you want to look at occupancy. What are occupancy? We always assume that all of them are actually awake and ready to actually respond to alarm, but not necessary. In fact, if you look at MS1183, now they look at different occupants, all right? Occupants who are awake and familiar with the building, occupants who are awake and familiar with the building, or occupants who are likely to be asleep. So you have many different types of occupants. Like in office, normally they are awake, they're okay, they can respond. What about hotels? Do you know that when human goes to sleep, their senses actually drops? That's why for alarm bell, decibel, the sound pressure level in the hotel room are 10 dBAs above what is outside. Let's say in a shopping complex. Normal minimum sound pressure level in a shopping complex is 65 dBA, but in a hotel room, it should be 75 dBA at bed 8. All right. So this particular MS actually is quite good. They give you actually guidance, further definition of different type of occupants under different alertness conditions, so that you can then actually look at the guidance for design. This is exactly what I say. In shopping complex, we have now smoke curtain that drops from the ceiling during a fire incident, and it depends on the critical condition of the flow of smoke. So you might want to have one that is longer, so that the egress route is along this side, so they protect the occupants from the smoke. And you created a temporary smoke reservoir, right? You control the smoke so they won't simply spread. But then, if you look at our current EL, they're all ceiling mounted. Virtually, you can't see the way I look at it. Practically, you cannot see in a fire condition on the floor on fire, which is the most important because the rest of the floors without the smoke, you can see actually quite clearly your egress path. But on the floor on fire, imagine a compartment, you can't, all right, because they're all obscure. So we have to rethink about a lot of things that is prescriptive based. This has been developed probably about 80 years ago. Is it still relevant? If it's not relevant, as professionals, I think we're going to review, all right? And you don't forget smoke layers are actually heated particles that can generate a lot of heat, okay? Coming out of the fire is about 250 degrees C. So of course, as it flows upwards, it loses the temperature. Still, you're looking at, if you stand below and this smoke layer is very, very low, probably you get your hairs burned, all right? Exit signs, we are still putting on top of the door according to the requirement of EBBL. I think we've got to start looking at marking the base of the door with something, all right? They are what they call intermittent panes signage. If you go to Korea and Japan, they actually mark the arrow along the skirting, right? So that at least, you know, in case the exit sign, the polar sign is being obscured by the smoke layers, you can still find a way to egress route. I will show you this. Now, if you look at Scandinavian countries, they now actually have it designed in the carpet and they are illuminated. So you don't have to go and look anywhere, just follow the arrow, even though you are crawling on the floor. Imagine that this particular corridor is smoke locked on the ceiling layer. You can still actually escape. And if you go to, what do you call that, in China, they now even put it on the shopping center floor, permanently illuminated, okay? A lot of airports in the world also now incorporate this concept, design concept. No more at the high level. Okay, time's up. I thought I got 5 more minutes.
Yeah, Tay, you can wrap up. I think we can give you another 2 or 3 minutes to wrap up.
Okay, it's coming to an end already. Can you release the? I cannot move the. I need to move the slide.
Oh, were you in control of the slide?
I'm not in control now.
Oh, I see.
That is in control of the slide. They stop the slide moving.
Yeah.
Actually, it's about 2 more slides. Two more slides, then I'll wrap it up.
Yeah. Pam, Naini, or whoever's in control of the slide, can you move the slide, please?
Can you release the control back to me? It's still not
Technical
moving.
support. Garis, anyone from Garis, please? Free up the control of the slide.
Okay.
Okay.
Okay. So this is another photo showing that, of course, some of the shopping complex, they have a lot of those discount arrows. Make sure that you do not follow the wrong arrow and end up at the wrong place. All right. Now, there are softwares now that can actually show you what happened during evacuation. And it's very interesting. Now, you can then see why there is congestion on the exit door. Above here is look at, there are 50 persons in this room, and this is a clock, what they call running. You can see people going down the staircase, how long it's going to take. and how many people eventually can get out of the building. You see, it's not like what we think. Everybody can go through the door immediately. No, there'll be a queue, and there's another scenario whereby imagine that if this is actually a very big shopping complex, people get impatient and somebody just walk off, wanted to go and look for another egress route, and a lot of people follow him. This is called follow the leader syndrome, and it happened. And this group of people eventually all die. They never come up. Instead of waiting patiently, they just actually move off. And the rest actually follow him thinking that he knows the way, another way elsewhere. Actually, it's not true. He just get impatient. So they are now quite good, what I call software that can actually simulate. And you can see where are the problems of the design. So it's actually quite practical to actually do simulations nowadays. It's not only a fire modeling simulation or FDS, but actually you can do evac simulation as well. So you can then look at also the clock that's running, whether is it still within the reasonable required safe egress time, or does it exceed the available safe egress time, depending on the looking at the fire risk, the what do you call it, the fire size and all that. So it takes about more than 1.5 minutes to evacuate 50 people. This is only double story. Okay. Thank you.
All right. Thank you. Thank you very much, Engineer Hao Giang. As always, with your presentations, there's just so much material there. Is at the end of it, in the given time, it's always as if we're covering just the tip of the iceberg. There's just so much down below that we just couldn't cover. We wish we have another 10 hours on this, but there will be room for another session after this.
We can always do more. As I say,
Yeah,
I can tell you 1 hour is not enough for me.
yeah,
It's
it's
not
never
enough.
enough. It's
Yeah.
never enough. It's
You look at so many side issues that, if I go in, it's become a full module, you understand?
Yeah,
So
yeah.
it's, well, food for thoughts. Anyway, this is good to start people thinking. I think this is basically what we are doing today, all right?
Yes.
Get people to start thinking.
Yeah.
It's not so simple.
Yeah.
Nowadays, with the
Exactly.
modern,
Yeah. We've turned on the light bulbs now in everybody's head, so now we have to keep it burning here. All right. We do have some immediate questions that we can go through. So okay, I'll just run through it now. Okay, we have the first question from Ao Hui Fang. Which regulations or guidelines can we refer to for the temporary holding area within the high-rise building while waiting for a rescue team?
Actually, there's none. At the moment, I do not think there is any provision for that, because that's why all the time we are still looking towards mass evacuation. So you are not supposed to go into any temporary holding. You know why? Because if you do that, and the fire marshal on the assembling area, they do not know you did that, so they cannot inform the fire authority that you are still up somewhere in the high-rise building. It's very dangerous. So my advice is that you just get out of the building until proper guidelines are being set up.
Yep. Or unless we go on the process of like how they did it at KLCC, where we specifically design from the very onset of the design of the building with a planned strategy of evacuation.
And even for KLCC, they do not have a temporary holding area. What they do is that they do not even initiate the evacuation at all. If they do not inform you to evacuate, means that you stay put and carry on working until say so, until being told to evacuate. So there's no such thing as evacuate and then go to a temporary holding area. No. So I think the concept got to be very, very clear. Unless you're talking about refuge area, then that's different. Those can be what they call that termed as temporary holding area. But in Malaysia building, there's no refuge floors. Unless you are in the hospital as a patient, then yes, they do have a temporary refuge area whereby they move you into that area if the situation gets very dangerous. But other than that, high-rise, definitely no. All right?
Yes. Okay, thank you. All right, the second question from David Ui. Is there a rule of thumb for area of assembly point comparing against volume and capacity of the buildings? This will be very closely related to the first question?
Frankly speaking, no as well. And if you look at some of the buildings within, let's say, KLCC area, let me tell you, it's so haphazard. Because you cannot get a proper assembling area. One of it, I think, is a building next to, what is the hotel? Last time it's Nico Hotel. What is the hotel now called? You know Nico Hotel Jelampang?
The Citibank building?
Yeah, correct. So across the road now, there's a new high-rise building. So if you look at the assembling point, where can they go? Around there, there's no empty space for assembly.
Jalan Ampang.
Jalan Ampang, as I say, next day, Star headline will be mowed down by motorbike, by the Grab motorbike, you see or not? So no, there's no SOP at the moment, which I think is actually another area perhaps we have to look into, all right? PAM, we have to look into as to, whether is it really safe, whereby there's not sufficient assembling point being set up for mass evacuation.
Okay. Another question from Ao Hui Fang. What is the requirements or regulations for lift which can be used as an escape lift during emergency?
At the moment, as I say, there's only 2 buildings in the whole of Malaysia that you can use lift for evacuation. One is Twin Towers. The other one is KL Telecommunication Tower. Well, of course, you're welcome to walk down the KL Communication Tower, which is smelly, lack of oxygen inside there. And that's why they have no other choice, because the tower head is so high up in the air. Normally, they will assemble everybody. If you go up to, let's say, KL Telecommunication Tower, they bring it down to the lowest level, which is a refuge floor, and then all the occupants will be evacuated by lift, high-speed lift down. So there is no provision at the moment. For KL Tower, for KL Twin Towers, it's very unique in the sense that at that point of time, it's all designed by the Americans. And they have provisions for, I think they have about 48 lift cars. And they work out the floor density, and that they can actually accommodate, all right? So you cannot use a normal passenger lift unless it's protected. First of all, the lift lobby must be protected. Secondly is that you need a group of management team to actually control the crowd. Otherwise, there'll be a lot of chaotic situations, stampede and all that. And the lift eventually could be overloaded if everybody try to squeeze in. Okay, so this is not for any building.
Okay. All right, another question from Ao Hui Fang. For the final exit with door leading directly to the outside air, what about discharge to an open structure car park at ground floor, which comply to UBBL? Can that still be considered as the final discharge, although it's still within the building?
I think for assembling point, it's still better to be outside the building, because you do not know what's going to happen. And actually, if you move into the car park actually is a higher risk area than the building, frankly speaking. It's all full with in fact, I talked about in the previous session, car park is high risk because it's full of cars that is full of plastic and full of fuel. And if you look at a car park, the risk is actually very high. I'm not saying that the fire will start there, but then I don't think it's appropriate to move a lot of people into a car park as a assembling point. You just have to go and look for a suitable place. You might have to walk for a while, but at least, get everybody out of the building. There's another risk that we are not considering. Imagine that if it is an external cladding fire, there will be flaming droplets all from this aluminum cladding falling from upper floors onto the street level, which is happening in so many cases that we saw. It's scary, yeah. And then if you look at the floor area, it looks like a war zone. Yep. Even cars are smashed. So you have to get away from the building during any fire incident to a safe distance. All right.
Okay, I hope that answers the question. Perhaps to add on a little bit to that, recently there has been a lot of cases from Bomba whereby plans are being rejected because a lot of escape routes literally does what you mentioned just now. It goes down to a car park level, and they said, okay, they are out of the main building, but they're still within the podium, they're still within the car park. And for all intents and purposes, the car park is still part of the building. So therefore, it will not qualify as a final exit. Final exit is really out of the building. Yeah. So and moving people from one compartment to another on the pretext that it's a horizontal compartment doesn't actually work if the compartment you're moving from one place to another compartment is of a different purpose group. You can have an office compartment moving horizontally to another office compartment, but not from an office compartment moving horizontally to a car park compartment to a purpose group of a higher risk than the one they're trying to escape from. Right? Okay, so those are the concepts that we just have to keep in mind. Okay, next question from Nozarif. Hi, when should we use the minimum stair width of 1.7 meter? Is there a minimum stair width of 1.7 meter anywhere? Or should fire staircase be enclosed with fire door or open staircase? Okay, yeah, Tay.
Okay. I do not know where the 1.7 meter comes from. As I explained just now, this is again prescriptive. What do you mean by 1.7? How relevant is to the egress design? How many people in the building? How many persons? What is the floor density? So I think at the moment I look at it, most of the IR and the AR I talk to are still so locked up in prescriptive thoughts. The mindset will have to change. In fact, people tell me, think outside the box. Do you know what is my thinking? Where are the box? You don't even want to have the box around. Yeah, it's not just thinking outside the box. There should not be any box. So it should be, we are supposed to be solution provider. You cannot be just following, take data and say, oh, if I design using this data, it's going to be safe. I just now pointed 1.12 meter per second for horizontal travel speed is meaningless. Okay, it's meaningless. So similarly, 1.7, you need to look at, people cannot travel two abreast down the staircase. No way. So you got to go and look at how many people are coming down. What is the density? What is the flow? How high? And staircase definitely will have to be protected with fire doors. Whether it's open staircase, not open staircase, you still need to protect. Don't forget, either behind that fire door is a smoke lobby or a protected corridor. You cannot have it. You can actually design with the open corridor concept, yes. But if you are having a fire staircase, if it's open, ventilated, well ventilated, comply with all the criteria, then perhaps you do not need the fire door. But then that becomes the final exit, isn't it? Story exit also, is it a story exit? Let's say if you go into a staircase with actually a ventilated staircase, you still need a fire door. You still need a fire door, okay?
Yep, you have a fire door. When you enter the staircase, it may be an open staircase, but if you're protected with a fire door behind you when you enter the staircase, that becomes a story exit. Yeah, so
Story
that
exit,
is
yeah, it's
actually,
a story exit,
yeah,
yes.
that's right. Yeah. Okay. All right. We have a very long question coming up from Chong Yu Chang. Mr. Tate, thank you very much for delivering such an inspiring talk. My question is, why is magnetic fire door retainer system? I believe this is the whole open
Yeah, yeah.
magnetic whole open.
Fire door, whole open device.
Yeah. Okay. Not implemented in high-rise buildings in Malaysia. Fire doors are so unfriendly to be used on a daily basis. Tell us about that, Tate. When we access to lifts or staircase. I've been to some buildings in Singapore and Sydney where magnetic fire door retainer systems is used. The system has well-mounted electromagnetic plates that links to the metal disc at the back, etc. It makes the access to lift and staircase so easy, especially for the elderly. Yeah, we do have that. Yeah, but this is on fire doors 1073. So that's your expertise there.
Actually, this is a very interesting question. Do you know that when the Alpha Abloy, Alpha Abloy is the largest lock set manufacturer in the world, all right? And their technical director from Shanghai called me up years ago and wanted to have a chit chat with me in Malaysia on his way back to Finland. So I said, what about? He said, I heard so much of the research work you've done. He said, I would like, to actually have a sharing session. So he brought along with him all the Asia Pacific ring manager. You know what I told him? I say, first of all, I disagree with you guys selling the magnetic door holder. He was shocked. I say, tell me, when you induce a magnetic, okay, now you need a metal plate on the door, right? So I say, correct me if I'm wrong. You put a metal plate against a magnet. After a long while, it's magnetized. Agree? So I said, whenever you release it, do you think you can physically release it? Secondly, I also told him, fire door when they are closed, the door closer acted minimum strength on the door. When you open the door to 90 degrees, you're subjected to the door closer to maximum strength. That's why it can then push it back to close. Imagine you open a door, subject the door closer to maximum stress and hold it open for years. By the time you release it, do you think it can close back? Okay. So what I did is that when we went up to, this is actually very funny. Three of us traveling up to Kuantan to give a fire rescue department Kuantan officer fire safety seminar. And we stay in Swiss Garden Hotel along the beach. And this hotel is quite new. One of them was with me, who is actually a project architect, feeling so proud. He said, look at the hotel, fantastically designed. I said, yes, two wing, every window or every room can see the ocean. And you have a corridor actually leading to all the, from the foyer, you have two wings, to a protected corridor, and they have a double lift fire door there. Okay, but this owner is even better. Instead of magnetic holder, he go and buy the small hook from the hardware shop, and he actually hooked the two doors to be open. So all the chambermaids can then push a trolley without any trouble. So I said, okay, let's do a test. So I released the two hook, and the two lift closed, the primary and the secondary lift closed, and leave a gap of 6 inches. This is only 18 months old. This is a physical test. So definitely it's a no-no. If you wanted to have a magnetic door holder, you virtually got to close it every day, every night. And you also got to test the door to make sure that not only it closes, it has to latch. Sometimes the door closed, the latch does not engage. And if the compartment inside have a fire, the air expands, you push it open, you lose your integrity straight away. All right, so you see a lot of places, they do something like that, doesn't mean they are right. At the end, he agreed with me because this has a lot to do with the functionality of the door closer. It's not just, keeping the door open, Actually, we also discovered that, of course, the cost is higher. They are actually automatic door closer that actually detects people approaching and open the door automatically. So after the traffic crosses, the door will then close automatically as well. This is actually being installed in many hospitals. So magnetic door holder is actually a cheap version, but it's not a safe solution. Okay.
Yeah, I'll add on to that if you permit me. I have actually installed an awful lot of electromagnetic hole open devices because in the applications of the buildings I design, especially in the high tech industrial factories, these are very 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 high-tech factories, in terms of the planning requirements, in terms of accessibility, accommodation, integration with safety, security, and production processes and all that. There is a great requirement for us to install that. The way we've done it is that, well, of course, a lot of these factories are also subject to ASTM standards and FM global standards and all that. Yeah, so they do self-impose on themselves a far greater, higher degree of standards as opposed to just a basic compliance with our local bylaws. So one of the ways in which we devise all this is that the electromagnetic catchers that we install, of course, they're all subjected to the correct wiring in terms of double knock alarms and all those things. But most importantly, it's actually the maintenance regime. Every single door is tagged, and we know exactly what's the installation. And every 2 weeks, the maintenance team will have to go around and log in a maintenance record. The door must be released at least once every 2 weeks, and to allow the obviously to demagnetize the plate, you have to release it to demagnetize it, and to allow the door closers, the springs to be released. Yeah, so that the thing is so yeah, they do have to do that. So as with everything else, whatever we install, first we have to get the best element that's available. You have to get the best car that you can afford to buy. Then please maintain it. Yeah, a BMW cannot run forever, even though you paid a lot of money for it. You still have to send it in for servicing and maintenance. Yeah, so I think that is one of the things that we as architects have to be very, very aware of. Don't just specify and walk off lah. Yeah. Right.
I think it's more than that. I mean, okay, you do, even though you do maintenance, the important thing is that the door will still have to function according to the Malaysian standards, moments, forces, closing, latching. In fact, if you remember just now, I showed a slide of the door that's opening. I talk about the path. You can, if you notice, there are latching force. There are also other forces that is talking about. In fact, I just got in a machine, or rather a handheld equipment that eventually we can even measure the moment of the door, closing as well as opening. So that will then, you can then stipulate or look at a table that is specified by Malaysian standard, whether it qualifies or not. And you don't even have to actually, it's not just releasing. Releasing is the easiest part. Can they actually close and latch?
Yep.
And latch, that's the most important. If they cannot latch, it doesn't matter whether you can release or not.
Yep.
So there are a lot of things that, let me tell you, do you know that for fire door standard, we lead the whole world? We are the leading because we got about 7 or 8 standards, even if for the ironmongeries. But I can tell you something, I believe very little architects actually went through all the standards that we have developed under my TC. Because a lot of the things, and at the moment, let me tell you something else. Architects still specified lock sets on egress route door, fire doors, which I think is overkill. In all the egress route, you do not need lock set. All you need is a latch set. When you test a latch set, a lock set is the same. They pass. But if you were to just ask for a latch set, you save so much because it's the lock that's expensive. I've been talking about for years. And also, you do not have the risk of people locking it up. The moment egress doors have a lock, a lot of times owners sometimes lock it up for security reason, which is going to be disaster. I tell you a bad experience I have. Last time I was in one of the hotels and newly opened. Okay, so my German principal came here in the fire industry. So he said, hey, let's check the fire escape. I said, okay. So we walked down all the way, from 20 stories until the ground floor. And the door was locked. And there's a small notice there. Kindly look for the maintenance people to get the key to open this door. Oh my goodness. Imagine the 500 people charging down behind my back, I'll be flat on the door. So a lot of hotels also remove the lever handle from the fire escape door, which is actually also contradicting the bylaw. Because you see, for security reasons, when they remove the lever handle, the moment you enter the fire escape staircase, you cannot come back to the floor. Or if you go down, you can go all the way to the ground floor to get out. Then it defeats the purpose of selecting an alternate egress route. Imagine down there is compromised, smoke is coming out, and you cannot re-enter the building. What is going to happen to all the people who are stuck in the fire escape staircase? So there are a lot of other safety issues that we are looking at, and the only way is to share it through this kind of platform and hopefully architects don't make this or are aware of this kind of issues. All right.
Yeah. We should arrange one very, very special session, especially on iMongry. Yeah,
Yes.
iMongry, the conflict between exit and security. Yeah, these two. I think that Tay, we should be able to do one session, 1.5 hours. We can cover just iMongry, right? On this.
In fact, I tell you, Lee Siong, I got so many papers.
Yeah, good. We'll put one in.
You see, every topic I talk about, I got a separate paper that is full paper. I can spend 2 hours talking about it, and then we can actually organize workshop or things like that. In fact, I want the architect to participate as well because they have a lot of query. They have a lot of different situations, and then we can actually properly, look at it and benefit everybody, which is good.
That's true. Okay, that's a message to Pam. We'll organize one session on that. One last question. The last one for today. In MS1184, universal design accessibility. This is universal design accessibility. It stated that for rescue purposes, staircase minimum should be 1.7 meter width, or that's where it came from. When should we adopt this, and when is it applicable? Well, this one is actually 1184 on the designing for universal access.
Yeah, but that
Tay,
is the
would you
minimum.
have
That is the
any-
minimum. So the question we're asking now is that means you cannot go below that. So what is appropriate? The question they should ask is what is the appropriate width? Appropriate width depends on the building occupancy risk, the floor density, and all that. So, okay, what that statement says is that you cannot go below 1.7. But that doesn't tell you that you should at least take that and design. Because each fire escape staircase actually caters for different emergency. So you architects should be able to actually look at the rest of the designing factors and then with calculation come up with an acceptable figure. All right, just like fire doors, Putrajaya have actually rejected. This has been installed in some Putrajaya project where by the fire door is only 0.7 meter, 0.7. Fantastic interpretation by the manufacturer of the UBL, yeah. At the moment, architect, I think also has been confused by, the manufacturer, they thought they know everything. No. At the end, the fire rescue department ordered all the doors, including the frame, to be removed. Huge, big problem. That's why they're even telling me, how can a fat guy go through a 0.7 meter door? After you left the frame, the door stop, and the handle and all that. If you're a bit too fat, I think you get stuck there already, forever. So 1.7 is only the minimum norm. We always do not design the minimum. You've got to design appropriate width. That means you've got to really look at calculating the floor density and all the factors that I talk about. All right.
Okay, right. Thank you, Tay. I think we have run out of time now. Thank you so much for all the participants and all the questions. Thank you, Engineer Tay Hao Giang, for your precious time. There's just so much more. We must see a lot more of you in the very, very near future. Right? It's always been a pleasure working with Tay in all our committees, in all the years that we've been together. It's always a pleasure. There's always this very, very good discourse running to and fro, and coming from an engineer's perspective versus an architect's perspective. Engineers and architects never mix, but when we do come together, the end result is always fantastic. Yeah, in serving what we have to do.
Okay.
So, okay, I'll pass it back to Pam.
Okay, Mr. Ting and Mr. Chong, now we have a photo session, okay?
Photo session.
Yeah, photo session.
Oh, okay.
Okay, all right. Okay, 1, 2, 3. Okay, one more. 1, 2, 3. Okay, free time. Okay, 1, 2, 3. All right, okay, thank you.
Okay, then thank you, everyone. Have a very good evening and a good weekend.
Yeah,
Thank
thanks.
you. Bye.
Cheers. Bye.